All right, let's get going then. So, hi, happy Tuesday. Thanks for coming. Happy short week of school. Um, so homework one is due tonight. The idea of it being due now is that you don't have to work on it over the break. So turn in what you have. And the other thing is it needs to compile. So if it doesn't compile, then I can't give you any points. So make sure whatever you turn in works. Um, so that's the thing about homework one. As like a grading note, I went through and I put 0 in for labs that I haven't received yet. So if you got a 0, then I need you to submit it as soon as possible. So if you're not working on the homework, maybe spend some time working on the labs. I'm gonna have a cutoff date for labs 1 through 5. Can I have you guys in the back listen up? Because this is really important. So if you have gotten a grade other than 100% on the labs, that grade's gonna be final as of next Friday. So if you have a 0 on the lab, if there's one that you haven't done yet, that's going to be final as of next Friday. So make sure you work on that and get that in. And because, yeah, that'll be helpful for you to be like, I'm not going to worry about this anymore. It'll be helpful for me to like not have to go in and grade it again. So just so you know that that's coming. The other thing, oh, question.
So is our grade on Canvas like grade as like right as well?
Yes. Yeah. So yeah, as I change the grade on Canvas, that's the grade that you're on track to receive. Yeah. Question.
Yeah, that's my grade because I saw you said that about the last. I was at 22%. What's last zero?
If you click on it, it will tell you.
Okay.
It's basically an introduction. It's the idea of you do that on the first day of class and tell me who you are. Yeah, so lab 0 is fine. You don't have to do that. I will excuse you, but the other labs are important. Any other questions about the cutoff date? Okay, with that, so I don't want to stress you out too much about that. So the first thing to mention is that I'm aware that the labs are not ideal. I was bringing this from another institution, and I like sometimes the assignments that work in some places don't necessarily work as well as you think they will in another place. And so that's kind of what happened with the labs. Like the instructions aren't as clear as I would like them to be. And that's my fault for not. That it's also like you don't ever really know until like you get there and you try it out. So that's on me. So with that, I'm in the process of rewriting the labs for next semester. And so I'm gonna have, I think, like an extra credit opportunity where if maybe you just want to like write off the labs that you haven't done. And as I come up with the new labs, I might give them to you and like if you didn't do the labs, then you can do those with better, more clear instructions. And then there's like replace them, or you could like get extra credit if you tell me this lab is good, this lab is not good. So that's also kind of on the horizon. I'm almost done with lab 1. So that's what I have to say about that. But for the existing labs, since we don't have the new ones yet, I am gonna cut us off. So yeah.
So the new log will just be like extra credit to same grade.
Right.
And then you just want us to like do them and then give you feedback.
Yeah. I mean, and that's completely optional, like not required at all.
No, yeah.
Yeah. But yeah, you can get extra credit for that. Yeah, because also like I'm trying to write things that are better explained and stuff. And so maybe it helps you if there's something like if I'm redoing lab 2 and you're like, I didn't understand the scanner. then hopefully that helps. Yeah. Any thoughts, comments, concerns, questions?
Oh, labs or about the system, you just,
Either.
no.
No? Okay. Other announcements I have, I've been asked to tell you the STEM Center is closing early tomorrow and they'll reopen on Monday because there's fall break. The other announcement is I'm helping out with one of the seminar enrichment programs. So I forget what year it is. I think it's seminar 3. Is anyone taking that?
Seminar
3, I think?
4. That's
I don't know. So there's a Turing reading. An Alan Turing reading.
Yeah, I know about that. He invented the computers, right?
Yes.
During World War II.
Yeah.
Smart man.
So in one of the seminars there, I forget which number it is, there's a reading by Alan Turing, who's this really famous early computer scientist. And one of the things in the reading that you will do for seminar is he's asking, can machines think? And so I'm part of a team helping to put on this event where we try and answer the question, can machines think? So we're going to simulate what's called the Turing test, which is something that he describes in the reading, where like people trying to guess are in one room, the people people answering are in another room, and there's like a computer between the two, and you're typing, and the people in one room are trying to guess, is the person on the other end a computer or a machine? So we'll be using ChatGPT to try and figure this out. I'm the person in the other room who is maybe answering as a computer or as a human. So it should be fun. So that's next Monday at 1:45 in Galileo 202 up on the 2nd floor. So it should be a fun event. Come and contribute and try and guess. We're trying to think, like, are students gonna predict it accurately? I think it'll be easy to tell, but we'll see. Okay, so then for the next few class periods, today we're going to be looking at linked list code. Thursday, obviously, we don't have class. Tuesday and Thursday kind of depend on how far we get today. So we'll see. We'll probably not finish everything today, and we'll have something to do on Tuesday. So Thursday is kind of up in the air, but we'll have lab 6 by then and work on that. All right, any questions or other announcements for the good of the class? All right, so here's my plan for today. First, we're going to review the drawings that we did last time, just kind of talk through. Then we'll get started on the code together. So I'll show you, like, we'll make the node class, we'll make the constructors for the linked list class, and like get everything set up. And then your job is to, you can draw pictures on the board as you go. I brought markers today, and write this code as much as you can of it yourself. And I'll walk around and be helping. But like, I could show you how to do it, but you doing it all is also a very important skill. So I'll get you started. And then if you've got the notes from last class and like the knowledge of how to do it, your job is to take that conceptual idea and put it into actual code. Okay. So as a reminder, we're looking at linked lists, where they're this sort of structure where we've got one thing that links to another. And so the thing that gets linked together, we call a node. And so we can draw a node as like a box and then draw a link from one thing to another thing. So a node is going to have 2 fields, data and next. So let's write the next, or the node class. So I'm gonna be over here in my in-class project. And let's add a new folder. I'll call it linked lists. And then I'm going to make a new class, and I'm going to call it node.java. And Java is thinking about it. Okay. It didn't automatically load for me. I think this is also why. So the new labs, they're gonna be in Eclipse. So
What? I don't know how to use Eclipse, so I don't know.
because I don't like VS Code
You got that for next semester or for this semester?
for next semester.
Oh, okay, okay.
Um,
You can do a little code on
Eclipse, so there's so many like I feel like doing Java with VS Code is just buggy.
that.
Like so many of you have had like little weird errors with VS Code, and with Eclipse, for the most part, you just don't have that. So anyway,
What if it's user error and not just like you blame the compiler?
I mean, it may be user error, but like the amount of times that Eclipse just works, okay, hold on. Let me delete this file because it's not doing what I want it to do. Okay, delete. Move to trash. New file. Node.java. There we go. Okay, so it's in my linked list package. And here's where we're going to use what we talked about, genericity, right? So we want a node to contain something. We want a node to contain some data, whether it's integers or, I don't know, a combo lock or a truck or something. We want a linked list to contain something. So we're going to parameterize node. So node's going to contain some type, and that type, we're going to call it T. And so node is a really simple class, right? It's just, the way we drew it is just a box. It's got data and it's got next. So we need a field called data. We need a field called next. What should be the type of data? A node contains something of type T. Data is supposed to be the thing that it's containing. T, yeah. So we set up here, we're parameterizing it with T. And so data, the type of data is T. And so then what should be the type of our next field? Node, yeah. And so we do need, it didn't autocomplete for me. We do need the T part after this because node is defined, like we define node, we've parameterized it. And so we need it again there. And so, yeah, so because next is always pointing to another node, it needs to be of type node. So next is always pointing to the next node. And whether that exists or not is not really our problem at the moment. It's, yeah, it's either something or it's nothing. And if it's nothing, then it's null. Okay, those are our fields. Let's do constructors. So let's have 3 constructors total. So let's have the 0 parameter. Let's have with when we give it data, and then let's have with both data and next pointers. So 3 options. And then So I can just do that first one and then let's do the others. So constructors, one of which with data and the other generate constructors.
You need to eclipse.
Yeah. And the other one is with data and next. And so for the 0 parameter, I'll just say this dot data is null and this dot next is null. I mean, technically this is redundant because it'll initialize it to null. But it is what it is. Is this big enough for you? You want it bigger? Or is it okay? I'm assuming okay. Cool. Let me know if you need that to change. Yeah.
Like, does it automatically assume that there's?
Yes. So yeah, so technically we don't need this. Because if you don't specify what fields get initialized to, it defaults to either 0 if it's an integer, false if it's a Boolean, or null for anything else. Okay. So those are the constructors. And then the only other thing is really just the getters and setters, which the default for this one, the default is fine. So I'll do right click, source action, getters and setters, and I want getters and setters for all of my fields. So we'll have two for each. And so that just gives us get data, set data, get next, set next. And that's really all that we need. Okay. How's that looking so far? Okay, so we've got our node class. We've got our node setters and getters. The node is very simple. This is all that we really want it to do. This is just a place where we're storing some information and we point to another node somewhere. That's all. Okay, so that's the node. Let me know if you need me to go back to the code at all. But that's the node. So we've got our data and we've got next. And so we talked about like the different kinds of links. You can have doubly linked. We're going to start just with singly linked lists. We talked about how do we insert things. How do we, so like to insert at the, what was this? At the beginning, we make our new node and we set the new node to point to the head of the list. Remember, the head is what keeps track of the beginning of the list. So that's the only field that, or one of the only fields that our linked list is going to have. And then the rest of it is just like the cases for us to insert. So there's the case of insert at the beginning, at the middle, or at the end. And so also these drawings, I think I've uploaded them to Canvas. Let me show you how to get there. So from the main page, if you go to the fall 2024 lectures, and then we go down, we're in week 8 right now. No, we are in week 8. Last time was week 7. And so I have the PowerPoint here, so you can open it or you can download it. And all the drawings that I did are here for you to review. Okay, so So yeah, so we've got our linked list. So let's make our linked list class. So I'm gonna make a new file. And so I've got some options here. Whatever you choose to name it, you just have to be consistent because I'm going to use the linked list in some later files down the line. So just whatever you name it, remember that, and then be consistent in other files. So I could name it like linked list, or I'm just going to name it LL dot Java. LL stands for linked list. That way it's short. And so for our linked list, we also want the list to store some type. So we're going to parameterize this as well. So our list is going to be full of some type, which we'll call T, and it's going to contain nodes that also contain that type. Okay, so from what we talked about last time, we want the only thing that is holding all of the data is the first node in the list, right? The head. So it's a node, right? And then we talked last time about adding another field. So tail, maybe? Tail could be an option. I'm looking for something different though. Next node, that's something that belongs to a node. Yeah. Yeah, like the size of the list. So that way we wouldn't have to like go through the list and count them all up every time we want to know how big our list is. So adding a size field helps us cut down on that and to increase the efficiency of our linked list class. Okay. So let's see. What sort of constructors do I want? Probably just one to create an empty list. So a 0 parameter constructor. So we'll say public LL and no parameters. So we'll say this dot head is equal to null. And what should size be? 0. There's nothing in the list. Don't count anything. Okay, let's have one more constructor where we are given a node. Or what do I call it? Call it node B. Let's call it lowercase node. Okay, I'll be honest with you. I was about to say like, let's just say 1. But there's a boundary case that I would argue that maybe we don't think about right now, but let's make a note of it and continue on with our day. What's the boundary case? How could this possibly go wrong and not give us the actual information that we want? Yes. Yeah, so if we're just given one node that points to nothing, then this would be true, right? If we're just given like a single node, then this is all fine and dandy. But if we're given a node that points to other things, like if we've got like 1, 2, 3 nodes, one after the other, then this isn't correct. So, um, so we probably need to verify that only one node is given. If we want to be sure about that, we can maybe say this dot head dot set next. if we wanted to, we could like break the links. Like just in case there was something after that, then we can say, nope, you're not pointing to anything else. I could argue also that maybe if we gave a node that's pointing to something else, we would want to like sort of like a copy constructor, where if we're given this list with things after it and we create a new linked list, then we would want to say, okay, if this thing had 5 things after it, now the size is 5. So maybe we wanted to, if we were making a more robust version of this, we would probably want to change this and update it somehow. But for now, let's not worry about that. So those are our options. Okay, so that's our constructors. And so remember, something that's really, really important with linked lists. We only know the first thing in the list. Everything else we have to iterate through in order to find it. So we can't say necessarily, like, if we've got LL, I don't know, let's say, maybe we've got a list of circles. And then we cannot say, let me just name it list instead. We cannot say list at position 4. We can't just say that, or like list dot get. We have to define what it means to get the 4th element in this list. So remember, for linked lists, we're kind of going under the hood and asking, how does this thing actually happen in code? So we're peeling back the layers a little bit and seeing, how does this actually work? So this sort of thing doesn't work automatically. We have to define what it means when we say list.get4. So that's our responsibility as the programmer. Okay. Let's see. We talked about inserting, we talked about deleting. So both of those have the 3 cases, beginning, middle, and end. Should have your notes from last time. If not, I've got these here. We talked about size. One option is to like traverse through. The other option is to make size a field. Okay, so I think I want to do, let's see. Okay, I'm going to do one method with you, and then the rest I would like you to work in groups and try it yourself. So let's kind of add those in. So one of them is empty. One of them is public void make empty. So those I'll let you do on your own. One of which is size. Let's see, what else do we have? Is make empty, toString. I'll just set these up with like initial things to return, and then you just change what's there. I had in one of my versions, I have a print list, so maybe we have this, maybe we don't. Find So find is the idea that I give you an element that is it in the list or not? And if it's in the list, it returns the index. So, all right, comment with this one. Or maybe like -1 if you don't find it. Okay, what else? So I would have you start with what we call the helper functions. And then we'll get to like the real meat and potatoes of this, which is the insert, where we are given some index and some data, where it actually inserts the element at 1 before the index. And then there's delete, where, what is delete? And where delete removes the element at location, at the index. And so for this, we should have all the tools that we need to get there. We know how it should work in theory. The question is, how do we do that in code? So for today, I'm gonna let you struggle a bit. I'll walk around and help. But this is our first draft. Instead of me telling you this is how we're gonna do it, makes for a kind of boring class period before fall break. So I would rather put the ball in your court and have you be thinking about this, and I'll come around and help. And so if you get through all of this, that's great. If you don't, then that's fine. We'll spend some time Tuesday and Thursday next week of fleshing this out and figuring out what we're trying to do. Okay, so that's this so far. I'm gonna do one of these with you to kind of show you how we use the node methods. So give me just a second and I will pull up this code. Get node, where's get node? There it is. Okay, so yeah, I almost dropped this whole thing. Okay, so together we're gonna make a private method which returns a node. And the method is called getNode. And the idea here is we are going to, let's say we're given an index. And so we're going to iterate through the list and we're going to return the node at the position that we're given. So we're returning the node itself, not the data. So if we wanted to get the data, we would, let's say we call the node X, we would say x.get data. Because if X is a node, we know how to get the data from a node. We've got our getter here. So there's a difference between the node and the data contained in it. So just so that you're aware of that. Okay. So to start, we need some edge cases. So first off, if we're trying to get the node, but we've got a list that's empty, we probably want to catch that before we try and do anything. So I'll have a check for if this list is empty, then I'm going to return null. So if I'm trying to return the node itself and there's nothing in the list, then I'm just returning nothing because the list is empty. Otherwise, we have options. So the first option is if we're asked to get the first node in the list, then we just return head I. That's not what I called it. I called it IDX. Again, so like if we're asked for the first node in the list, that's easy. We know what the first node is. It's just the head. The other case is, let's say we're asked for something bigger than the list is. So like if our list has 5 things and we're asked for item 10, we should flag that. So if the index is greater than size, should it just be size? Should it be size minus 1? Size minus 1, why? Because we start counting at 0. So that's an option. Another case could be that like if we're given something less than 0 for some reason, then we want to flag that as well. Maybe here we throw illegal argument exception. Where it's out of bounds. Okay, I think those are pretty much all the cases that I care to think about. So now we're gonna actually iterate through the list. So there's some options for how to do this. We can have a while loop. The one I've got in my notes is a for loop. As you're iterating through the list, just keep in mind that there's different ways to get there. So for me, I'm going to need a node that starts at the beginning and goes through until we reach the index that we're looking for. So I'll need a temporary pointer. I'll call it temp. And we'll start it at the head of the list. Actually, let's see if this works. It should work. So if I put that in a for loop and I say, okay, there's different ways to get there. Let's do one way, which is the actually no, I don't think this is gonna work. So my thought was I have a temporary pointer starts at the head and goes through until we reach the thing that we're trying to reach. The problem is I don't know where we're trying to reach. I only know the number. I only know how many steps I'm supposed to go. So I don't think I could initialize the for loop like this. I think I have to have like an integer to keep track of where I am in the list. So if I have I start at 0, that's the index of the head, and I is less than what? When do we want to stop looking for this thing? Size -1? No, because because we're given like in a list of 10 things, we're asking to get the 5th thing. So we want to stop when we get to the index that we're given. So I've called it IDX for index. And so we'll start I at 0. We'll keep going until we've reached whatever number we've been given, and then just add 1 every time. And then the idea is we start temp pointing at the head, and then for each time, you got an idea? Yeah, so it actually ends up being, so we want to actually, so we do want temp.getNext. Yeah, so we don't want temp to stay pointing ahead. We actually want to move it to the next node. So we do say temp equals, or not temp, that's what do I call it? TMP. So temp equals temp.getNext, and that reassigns it. So remember, assignments go from right to left. So now temp is pointing at whatever was next. And then what do we return? Yeah, so we're returning the node at a certain index. So let's just, once we finish this for loop, we've gotten there. So hooray, go us. Okay, so let's see. It's never used locally. That's fine because the rest of the class hasn't been defined yet. So this warning is fine for now. Okay, so you should use getNode in some of the more complicated methods where if you know the index, especially when we're doing like insertion and deletion, where like first we were talking about getting there, getting to a node in like for deletion, use getNode. Because we know the index, the I-1, that's the index. So use that. Okay, so we'll take, I guess, the rest of class time and just work in groups and try and figure out what this code should be. So I've given you the constructors and getNode, and so work as much as you can with the other ones. Here, I'll pause the recording and we'll go from there.